generate a fair amount of dust too.
Yeah, it will. Yeah, we got our own. This is a custom-made dust collection system. Sourced from one of the shops. So very user-friendly.
Yeah.
No.
Make sure you flip that through.
I'm gonna have to stop and go down because that part's not right.
Something goes wrong
How do
with
you
that
sense the
language.
position of the tool?
So
you zero
keep
it first,
reminding
you tell it
It
something
knows how many
wrong.
steps.
Oh, do you have the coders on the...
The step
Right,
is-
that's where the calibration.
counting, right.
Okay, so watch your hand.
And then it all goes from the zero to the
Yeah, we got it. We debugged the custom.
I was talking about too. So here are all your limit switches, and this is actually the picture I used in the presentation, where the home can slide over, because that'll come to this block right here. So the home will slide or the limit will hit. Like I said, so the problem being is once that limit switch is hit, so we have a one-way switch in here with a nice cover on it so it can never get hit. And when you're holding that switch up, you're overriding your whole limit system. So what that does for you is it allows you to get off your limit. Because once that switch is hit up, you can't ever leave it until you override that system. So that was just something we didn't see coming. And the first time we ran it, put it to a limit, we're like, oh, now we can't leave.
That's a problem.
So I'd say that's one thing we learned definitely.
Can you show it doing that?
Huh? Yeah, I can show that.
You just jog it for that?
Yeah, I can run it. I don't know which one's going to be the
What is
slower.
this? The Z.
You wanna go up?
Port on
Just go to
each
Z.
switch.
Yeah.
Well, the problem is that
Well, the Z is our slowest axis at the moment. I'll run it out to Y.
it's yeah, I know. You have a limit switch for this direction, and you hit it.
So here you can see, if you guys look close, I got an X limit, right? My X or my Y home and my Y limit are right here. Same type of situation. It's going to roll over this, and then the limit's going to hit it. So once the limit hits, most CNC machines will have a light on them. This one kind of doesn't. So see, it just hit that, put it in an E-stop position. So now I can't go anywhere with it. I can.
So without the switch, you would be
Right.
stuck in that position.
So I can
without
restart?
you'd actually have to edit the programming to actually reverse your switches to actually be able to get it off.
So what we came up to fix it is you just simply, you hold up on that overriding that circuit, you reset your machine, and you be very careful when you move it. You make sure you move it the right
And then
way.
once you hear the switch click,
And once it's
you
off,
can move
you
it
gotta
off.
let go.
Release the switch.
But if you move it the wrong way, and the part that hesitates me about the switch is, if you move it the wrong way, you're going to break that switch, you're going to break the switch off, and you're going to put the machine somewhere it shouldn't be. So that's why we went with the one-way switch. It can only be held up, unless you're sitting here holding this up the whole time you're running it.
Yeah, it's momentary.
Right.
Right.
So,
And we contemplated on not even involving that switch in there and actually having people have to physically
change
either
the
get
circuitry.
someone to come and help them or have to physically do it themselves, because that way it would, prevent people who don't necessarily or aren't necessarily as experienced with the machine from self-destructing the machine. So it was a self-destruct switch, but it was something that was necessary, and it was an easy fix for a basic problem.
And we just did, this is just, as you can tell, it's a small ski. We just took a couple sizes, threw it together, and it's just the 2D milling of it. So when he's going to do his cores are longer. As you can see, that's an actual
So
core
students
size.
just cut these out with
Those
a
are by
jigsaw.
hand.
We have no other way of doing it. We print
And-
a CAD drawing,
Yeah. Can you grab that?
and then
other
you
one,
cut
too,
it out,
so
and you glue it on to a piece of wood, and then you just cut it with a jigsaw. That's the
Yeah.
value of this machine, is they can just take a
Yeah.
CAD drawing and just
So
cut
then-
it directly.
If you take a look at this one too, you can see how it's thinner on the ends. And these actually get down to 2 millimeters. So I think I had it in my slide. I don't know if I touched on saying it. Needs to have accuracy of better than that. So it has to be that, or else you're going to run into issues there. So this is going to do, I think the fastest way for us to program it with the speed of this machine is going to be, so it's cutting its outside and it's doing its Z back and forth at the same time. There's a couple different ways. You could machine Z the whole length of it, but it's, like I said, slow moving. So I think if it went back and forth, it'd be better off, but we'd have to play with that, and we will play with that, I'm sure, in the next week to get it to route a full ski core.
Yeah, right now we do all this by hand.
Right,
Like
that's
you
all
put it on a
hand.
wedge and
There's
send
a
it
lot
through a
of
thickness
potential for
planer and
human
crank
error.
it down, and it takes a long time. So this is a big advance in terms of just putting down a piece of wood and having it cut directly
And
from the CAD
another
file.
another upgrade that we would do if we had more time with this project.
Which you do, you have next week.
Right, would be to add a vacuum setup, so that way like a vacuum table setup, so that way it would be able to have a quick switch option, so you can pop in a board, cut what you need, or cut your board into what shape you want it to be. Then you could actually turn off your vacuum, reset the program, put another board on, and run it again, and so you can actually increase your productivity a lot.
You got any questions?
Why not have a sensor on each limit switch, an interface?
Okay, so there is a different way to do that. The way this board is wired, we don't have the ports for it. We could do add-on ports to the board, and there is actually within the software AX++, AX-, so you can individually wire every switch. With this board, we don't have the ports on it. So what we decided to do, I guess I decided to do, was put it all on one circuit. Looking back on it now, if I had more time, I think you can expand that board. I would have had to look into it. I think you
Either
could
that,
get
or
it so
you could
wire
you
out
could
boards.
buy another control board. They make upgrade control boards for these. Like these systems are very user friendly and easy to upgrade.
And the thing with that too is that would be nice for problem solving, because if you did hit an X plus and you're running the machine, you didn't realize it, you could have it saved in here as an X plus plus pin. So it'd come up as X plus over travel, and it'd show up right on your screen, so you knew exactly what happened exactly at that moment. Instead of, oh, it hit an emergency. We know because we've been working on it, we built it. Now somebody might accidentally come up and hit this Z, not realize they're on the limit, and why can't I do anything? Whereas if it was wired that way, it would say that. So that's one advantage of doing it that way.
This one sounds big. How is the board kept in place when it's running?
It's screwed down.
Right. The MDF is kind of a
all right, now,
sacrificial.
so if an actual application, say you wanted to put a fresh board there, how would you secure it on there?
So basically, what we did was like actually with this
That's
one.
why we want to put a vacuum table.
Right, with this one we actually screwed it in its exact same size as this board, and so we did the same measurements and then screwed it into the same holes.
And the perks, so another perk of a vacuum table is I can show you on this one. So like I was saying, when we machine, if we were to machine across the end, so this one we're going to have to do all that inside machining first, and then we're going to have to cut the outside. Now it's probably a better idea because it's down to 2 millimeters on the end. But if you were to have a vacuum table, you could set this down, cut the contour of this. If your vacuum strip's in the middle, you could then turn around, take the outside off, and machine all your 3 dimensions. And that's done a lot in common practice, so then you don't have a big chunk of material in there. With set up the way it is now, it's going to do all the 3D milling, then cut the contour so it's still attached to the actual board itself. Because, I mean, you could put screw holes in here, but I don't know if he wants that in his product. So you're going to
And you're going to want to avoid it with your end mill so you don't send
and you
screws
would
across the
definitely
roof.
And so another reason why it's not a very big deal for us to put screws in this is because actually this is a multi-layer system that we have. We have a base layer with there's actually 2 layers of 3/4 inch MDF here, and so the base layer is actually mounted down to the aluminum frame itself. And
This
so
is
then
kind of
this is
a
another. So
sacrificial
this is a sacrificial layer. It's another 3/4 inch layer that's actually screwed down to that base layer, and we use 3/4 inch screws. So they 1 inch screws, so they go through the 3/4 inch, but not through into the layer below. And also, it's very easy to replace. It's 10 screws holding it down.
You're like, this is P-Tex. This would be harder to do without a vacuum table. You
It's
don't
actually
want to
built
put a
to the
screw
end.
hole
He
in
wants
this,
to be able to
so.
cut that. More information on ski molding is that's another layer within the ski. That goes within the mold.
That goes on the base layer.
Let's go.
So he
bottom,
wants
yeah.
to be able to cut that to
Okay.
the same size without having to cut it by hand. So doing something like that, screwing it down
This is
wouldn't
cut
work.
by
You
hand.
would need a vacuum table.
Right.
I wouldn't let him make a vacuum table till the thing was working.
He
so.
would.
Right. Well, no, and that was a good.
Get
that was
the
a
thing
good,
working first.
That was a
Is
good
that
idea,
not a
because,
good idea?
because this didn't start working until Thursday.
Exactly. We fought on that one about 8 weeks ago.
You've dealt with these guys before.
Yeah, we butted heads on that one.